Hello viewers, welcome to my channel. I'm Hasham. So already two topics I've completed in the subject statistics for management. The first two topics are measures of central tendency and measure of dispersion. In these two topics, first video I have given the complete theory of the concept. Then a number of problems videos I have uploaded. So if you have watched all those videos till now, you got a good command of these two topics, measure of central tendency and measure of dispersion. Now I am going to start the third topic, that is measure of skewness. So in this video I am going to explain you about the concept, about the meaning. What is skewness? What are the different types of skewness? What are the tests of skewness? And what are the differences between dispersion and skewness? What are the measures of skewness? All these things I'm going to explain till the end. Don't leave it. So without understanding the concept, you should not go to problems. That is my suggestion, advice to you if you want to complete command on the topic. So take a screenshot of the points of skewness, then I'll explain all the points regarding skewness. Come on, first of all, the measure of central tendency. The measure of central tendency is the study of averages. An average plays a very important role in studying the data. The average is a representative of a mass of data. Then secondly, dispersion. Dispersion explains how the items are dispersed or scattered around the average value. Is the scatterness more or less from the central value? That is the measure of dispersion. But these two measures are not complete. The complete information of the statistical data we cannot get by studying only measure of dispersion and measure of central tendency. One more study is required called measure of skewness. This measure of skewness will explain about the shape or pattern of the distribution. Shape or pattern of the distribution will be explained by this measure called skewness. So first, the measure of central tendency and dispersion do not adequately describe the distribution in the sense that there could be two or more distributions with the same mean and standard deviation, but still different from each other in respect of shape or pattern of distribution. So this first paragraph I have explained that in spite of same central tendency, in spite of same dispersion, two distributions may be different regarding the shape and pattern of the distribution. To understand the shape or pattern of the distribution, we apply the concept of skewness. Skewness means lack of symmetry in a frequency distribution. Lack of symmetry is called skewness. So first of all, you must know what is symmetry. Symmetry means equal number of items are falling below and above the mid value, central value. When equal number of items are there on the left and right of the central value, it is called symmetry. Lack of symmetry is called skewness. If equal number of items are not there below and above the mean value, then we can say the data is skewed. So skewness means lack of symmetry, and symmetry means equal number of items on both the sides of the central value. Now symmetry is implied when data are distributed in the same way above and below a middle value. This is the meaning, definition, symmetry. When the data is equal above and below the central value, then the data will be called as symmetrical data. According to Croxton and Cowden, when a series is not symmetrical, it is said to be asymmetrical or departure from symmetry of a distribution. If there is lack of symmetry, it is called skewed or asymmetrical data. In real practice, this thing only will happen Very rarely we will come across where the data is symmetrical. Most of the cases we come where the data will not be symmetrical. One side the data will be more, the other side data will be less. For example, central value. If you find all the items from central value, more items will be above, less items will be less below. Or more item will be below, less item will be above. Like this we will come across, this is called skewed data or asymmetrical data. Asymmetrical means lack of symmetry. Symmetry means equal, both the sides. So values on one side of the distribution tend to be further from the middle than values on the other side. That means if you see the values from the middle value, so on left side the items will be more than right side, or right side the items are more than the left side. Then it is called asymmetrical data or skewed data. Now in a diagrammatic form, I can be able to explain. A frequency distribution could be a symmetrical distribution or a skewed. Two types of distributions are there. One symmetrical distribution, another skewed distribution. Symmetrical distribution means equal data, equal items are lying on left side and right side of the median of the central value. That is called symmetrical. Skewed data means the data, the item will not be equal. On one side more data, the other side less data. Then we can say it is a skewed or asymmetrical data. In a symmetrical distribution, the values of mean, median, mode will coincide. One of the feature, one of the property is when the data is symmetrical, lack of asymmetry. When the data is symmetrical, mean, median, mode, these three measures will coincide. That means mean is equal to median is equal to mode. The spread of the frequencies is same on both the sides of the distribution. Where in a symmetrical data. In a symmetrical data, the frequencies are same on both the sides around the central value. Now diagrammatic, how it will be, the distribution, how it will be shown. So three diagrams I have taken. Symmetrical or normal distribution. This you can see, this is the shape of the distribution. Central value is the mean value. Now you can find out equal area on left side and right side. That means exactly 50% of items are there on left side and 50% of items on the right side. The area on the left and the right will be equal. Then it will be called a symmetrical or normal distribution. Now positively skewed distribution. Lack of symmetry. Lack of symmetry means skewed. Positively skewed. In positively skewed, the left side number of items are less and the right side number of items are more. So the shape of the curve will be like this. So you can clearly observe here from the diagram, left side the area is very small, whereas right side the area is huge, large area on the right side. So if you get this type of distribution, then you should say it is a positively skewed distribution. Right? Now negatively skewed distribution. If more area is lying to the left side and less area to the right side. So closely if you watch this diagram, you can find left side the area is more, right side the area is less. So it is called a negatively skewed distribution. That's it. So I have explained you the meaning of the term skewness. Secondly, I have explained you about the different types of skewness, positively skewed and negatively skewed. Now test of skewness. How we can be able to find out whether the distribution is skewed or symmetrical? Whether the distribution is symmetrical distribution or skewed distribution. What are the tests? So three tests I have specified here. First, when the values of mean, median, mode do not coincide, there is a symmetry. There is asymmetrical data. There is skewed data. Distribution is skewed if the mean, median, mode do not coincide. If all the three coincide, it is called symmetrical. If all the three do not coincide, it is called asymmetrical or skewed. the skewness is present when all the three do not coincide. Next, quartiles are not equidistant from the median. In the previous video, dispersion, I have explained you about quartiles. Quartile will divide the distribution into 4 equal parts. First quartile, second quartile, third quartile. 3 quartiles are there. Q1, Q2, Q3. But Q2 is nothing but the median. Q2 and median are one and the same. So only 2 quartiles are left, Q1 and Q3. Lower quartile is Q1, upper quartile is Q3. Now, in case of skewness, the quartiles are not equidistant from the median. From the median, if you measure the first quartile Q1 to median, the area will be different. Then the area from median to Q3. Suppose if I draw a diagram like this, you can see here this is the distribution. The central value is the median. The central value is the median. Now Q1 will be on the left side, here Q1, here it is Q3, third quarter, lower quarter, upper quarter. Now the area from the median to Q1, suppose the area from median to Q1 is this much, Q1, whereas the area from median to Q3 is this one. Now you can observe here, it is not equidistant. From median to Q1 is a large area. From median to Q3 is a small area. This will happen when there is skewness. If there is no skewness, symmetrical, then the quartiles will be completely equidistant from the median. That means median to Q3 and median to Q1 will be equal if it is symmetrical. If it is skewed, it will not be equidistant. The quartiles are not equidistant from the median. Third test, data when plotted on a graph will not give a bell-shaped curve. If you plot the data on a graph paper, the curve will not be a bell-shaped curve. This is a bell-shaped curve. Bell-shaped curve means equal area on left side, right side. This is a bell-shaped curve. And this will happen only when the data is symmetrical. But when skewed data is there, it will not be a bell-shaped. This is not a bell-shaped. This is not a bell-shaped. These two are not bell-shaped. So when it is not a bell-shaped, when the data is skewed, that's what. These are the tests to find the skewness. Now what are the differences between dispersion and skewness? There are many similarities as well as differences. Now we focus only on differences. Measure of dispersion and measure of skewness, both are different concepts. So what are the difference? Dispersion is concerned with measuring the amount of variation of a series. How all the items are varying from the central value. Variation of all the items from the central value is the dispersion, right? Now skewness is concerned with the direction of variation of the departure from symmetry. The skewness will study about the direction of variation. Where the variations are more, where the variations are less. That study of the direction of variation is skewness. Whereas no direction, only scatterness, if we study, it is called dispersion. First difference. Second, dispersion gives us the extent to which the values of a given series are scattered. Skewness explains the extent and direction in which the distribution differs from symmetry. How the values are scattered, whether the values are more scattered from the central value or all the values are very much cluttered to the central value, that is the only thing we can get from dispersion. But skewness will tell not only the distribution but also the direction. Where the items are more, where the items are less. Whether the items are more on the left side or whether the items are more on the right side. That will be explained by skewness. Thirdly, dispersion tells us about the composition of the series. Skewness tells us about the shape of the series. Very important difference. Dispersion will explain how the values are deviated from the central value. Whereas the skewness will study the shape, whether it is bell-shaped or skewed on one side. Next one is dispersion helps us to ascertain the extent to which central value is representative. Suppose if the dispersion is very less, if this dispersion is very less, we can say the central value is representative. We can rely on the value of central value because the dispersion is very less. So by studying the dispersion, we can say whether central value is reliable or not reliable. That idea we can get by studying the dispersion. But skewness deals with the nature of variations on either side of the central value. Skewness will only study the nature of variations on either side of the central value. Either side means left side as well as right side. That's it. So these are some of the differences between dispersion and skewness. Now last and final topic of this theory of skewness is measures. How to calculate the dispersion. The two measures are there, absolute measure and relative measure. Absolute measure of skewness will simply mean minus mode. Simply you calculate mean value minus mode, you can get the skewness. If you get plus positive value, it's positively skewed. If you get negative, it is negatively skewed. So this is the absolute measure. A relative measure of skewness, two formulas are there. The two formulas are Pearson's coefficient of skewness. It is the symbol of this is SKP, skewness by Pearson. Pearson's coefficient of skewness, SKP. The formula is mean minus mode by standard deviation. Mean minus mode by standard deviation. But sometimes mode is ill-defined. That means we cannot get directly mode. In that case, indirect formula is there for SKP. SKP is equal to 3 into mean minus median by standard deviation. So, if we get the mode, we apply the formula mean minus mode by standard deviation. If we do not get the mode, it's a bimodal series, or mode is ill-defined, then alternative formula of SKP is 3 into mean minus median by standard deviation. One point you remember, skewness is based on measure of central tendency and measure of dispersion. Because if you are not perfect in calculating the mean value or mode value or standard deviation, you cannot apply the skewness. So before going to solve the problem on skewness, you must be perfect on how to calculate the mean, how to calculate the mode, and how to calculate the standard deviation. All these things, number of problems we have already done in the past videos. In the measure of central value, central average, and the second measure of dispersion. Right? Now, Bowley's second measure of skewness is Bowley. Bowley has given a formula to calculate skewness, but this formula is based on quartiles and median. It is not based on mean, mode, or standard deviation. So Bowley says SKB. SKP is the symbol for Pearson and SKB is the symbol for Bowley's coefficient of skewness. SKB is equal to Q3 plus Q1 minus 2 median divided by Q3 minus Q1. Q3 stands for upper quartile and Q1 stands for lower quartile. So you need three things: lower quartile Q1, upper quartile Q3, and median. These three things if you have calculated, you can simply substitute in the formula. Q3 plus Q1 minus 2 median divided by Q3 minus Q1. That's all. So this measure is also called quartile measure of skewness. Sometimes in examination it will ask you calculate the quartile measure of skewness. So don't get confused. Quartile measure of skewness is nothing but Bowley's coefficient of skewness. That's so in this video I have completed the explanation regarding the meaning of the term skewness. I told you lack of symmetry is called skewness. That means equal number of items are not there on either side of the central value. If equal number of items are there on left side and right side of the central value, the data is called symmetrical data. Symmetrical data. Asymmetrical data or skewed data will arise when left side more item, right side less item, or right side more item, left side less item. then it is called skewed. Skewness will be there, right? So skewness will study the shape or pattern of the distribution. So I've explained you completely. In the next video, I'll start the problems. If you are satisfied, give a like to the video. Share my channel in your group, in your friend circle, so that more students can watch the video and enhance the knowledge. Give your comments and don't forget to subscribe. And also, I've started a second channel for IGCSE students. The channel name is Hans Accounting Institute. The link is given in the description. So even if you just to type Hans Accounting Institute in search, you will get the videos. Watch the video, enhance your knowledge. Particularly the second channel, Hans Accounting Institute, is meant for IGCSE students. Inshallah, we'll continue the problems on skewness in the next video.